Laptop. Earlier you have laptop. So that okay. So practice it. Go to lab. AC is there. Cool water is there. So many people are there. Everything is there in that. Okay. Fine, students. Today, listen. Now, let us start the next topic. Important topic. And multi-threading. Multi-threading in Python. Multi-threading in Python we are going to talk. So this will take 3 days. So now I'm talking about index. Very, very important. When you go to normal companies, they don't ask any questions in multi-threading. When you go to bigger companies, you'll come across questions in multi-threading. And it is, people will feel it is typical, but whatever we said so far, you will easily learn it, not a difficult. So just start understanding about what is the index. What we are going to discuss in the index. There I am saying purpose of why multi-threading. Purpose of multi-threading in Python. Even multi-threading is .NET, multi-threading in Java also. Multi-threading in Java and multi-threading in Python. Concept is same, but what is different? Syntaxes are different. Next I am talking about types of applications. Types of applications. Types of applications. There I will explain process-based applications, easy, you can understand. And second one is called thread-based applications, thread-based applications. There we will talk about definition of thread, and next we know purpose of thread, and definition of thread, purpose of thread. Next we talk about introduction to thread-based applications. Thread-based applications. We'll talk about it. Here we'll talk about very, very important. And there you will come across types of threads. Types of threads you will come across. There you will have what default thread name, default thread. We call it as what main thread. Second one is called a sub or what child thread. What is the use of that? And next we will talk about module name for developing thread-based applications. Module name for thread-based applications. There we are having the module name, threading. What is the module name? Thread-based. Next we will talk about a detailed description about it, followed by programming examples. So in today's session, I will be talking about example also, but I will talk about this 17th line in detail in next class. Next we will talk about detailed discussion about threading module. There I will write it. Detailed discussion about threading module. Very important. So there I am writing threading module we'll talk, and after that followed by immediately programming examples. One I write it. Number of approaches for developing thread-based applications. Number of approaches for developing thread-based applications. There we will talk about using functional approach. Second one is what? By using object-oriented approach. By using object-oriented approach. Oops, already done. Object-oriented approach. So, there we will talk about programming examples. This is called the first area. Today we will discuss of, and next we will discuss rest of them after that. And today and tomorrow I will discuss this complete part. Today few parts I will discuss, next also, tomorrow also will come to that. And the third day we will discuss about very, very important synchronization in multi-threading. Synchronization in multi-threading. It is also called as what deadlocks. It is also, I can write in another way, deadlock occurrence. It's a very, very important. Deadlock occurrence and its elimination. In Python. Next we will talk about, that is a single topic. Importance about, or I can say implementation of deadlock elimination by using lock class. Implementation of deadlock elimination by using lock class. There I am talking about programming examples. This is the index of this completely. This is the index of multi-thread. Okay. So first part and then second part, students. Let us start the multi-threading importance. Why this multi-threading concept is required? What is the use of this multi-threading and all? So let me start introduction to multi-threading. Before the introduction to multi-threading, or let it be, things I will discuss after that. I'll discuss types of applications in real world, and multi-threading comes under what I will discuss. First term, types of applications in the context of multi-threading. Take one best example before entering into the further discussion. One best example I want to take up. Carefully follow, students. Online students, carefully listen. Now I'll go to some small discussion now. So there, opening this paint screen, carefully follow. Take an example of one small diagram here. This is a small diagram I am trying to illustrate the concept of multi-threading, which is already present in our products, which are already using with us. This is my OS. What is the use of OS, students? What is the use of OS? Come on. In my system, I am using Windows 10. I am using Windows 10 OS. I am using. What is the use of OS? Which I said in the class earlier already. OS will provide the resources to my program like hard disk and keyboard, like memory, like CPU resources. So many hardware resources will be provided to my application when it is executing. And when the application is executing, those resources will be taken back. That is known as what? Resource allocation, and resource deallocation can be done by what? OS. Okay, right. Take care. And in my system, I am opening Python command prompt, Python shell, PDLE shell. Now I am opening something like, PyCharm. I am opening here called Oracle. Here I am opening something like, MySQL. I am opening MySQL. Here I am opening Jupyter Notebook. Here I am opening, something like Paint. Here I am opening something like what, some other database I am using it. So here I opened it what? Python command open, CMD open, CMD, Python command prompt open. Here I open Python ideally open. Python ideally open. Next here I opened it Jupyter notebook. Jupyter notebook open. Here I am opening something like Oracle application. Here I opened MySQL. Take care. And I am getting the threading importance here. Next I opened here Paint. Some Paint app I opened it. Here I opened it something like, Edit Plus I opened it. Edit Plus I opened it. Here I had one music player, Spotify. I opened Spotify. So coming to the point of it, Spotify opened. Now take care. Now your Windows OS will provide this one by one, all at once. Huh? One by one, all at once. All at once. Tell me what you are feeling. First of all, you did not open. That's what your problem is. So, or otherwise you take it. Actually, when I open these many number of applications, my Windows OS will provide services parallelly to all my applications. To all my applications, services are provided parallelly. Are you able to follow me? To all my applications, services are provided parallelly. What did you understand about this mechanism now? This type of parallel execution by one single OS comes under what? Concurrent execution we call. Spell out. Concurrent execution we can call. So Windows OS is going to provide the service to what? MySQL, Oracle. To all these things are provided, concurrent execution is provided. Simultaneous execution, parallel execution is simply called as what? Concurrent execution. Spell out. One by one execution is known as what? Sequential execution we can call. How many types of execution mechanisms? Two. One is one by one. One more is this type of execution is comes under what? Concurrent execution. Are you able to get it out? Take ATMs, you take it, ATMs. Just imagine SBI server. Any person goes to the ATM center which are spread across globe, which are processed by single server of the SBI or not? What it is called? Is one by one entering into one ATM center or across the globe, all of them entering in different places? So you are in Amirpet, I am in somewhere, I am in somewhere, all of them are parallelly working or not? These are all SQL requests are processed by single server. What is that single accessing at a time by multiple people? Concurrency. Word called what? Concurrency. So that Windows OS is providing what? Concurrency or sequentiality? That concurrency is provided by multi-threading concept. So far, what we executed is one by one only we executed. From today, we are going to execute our applications all at once. We call it as what? Concurrent execution we can call. There are two types of execution mechanisms are there. One is sequential execution. One more is concurrent execution. One more example I will tell you because you did not still catch me. Take your example. And your example means practical example. This you should not tell in interviews because I decided to tell you with Windows, but you did not catch it. That's why I'm going to give you this example. And you are the student in my class. What are you doing? Tell me. First, you tell me what are you doing. That is more. Still, if you don't tell, you are wasted. Start. This is a student in the class. Is a student in the class. First, let me write it. Student in the class. It is nothing but a Python program. It is nothing but a Python program. Tell me what the student is doing by sitting in my class. Number one, what are you doing? Listening the class. Listening up. After that, what are you doing? Writing up. Are you writing? Are you writing? Are you writing? Wait, nobody is writing. Okay, right. Next, listening. Next, writing. Next, understanding. Only writing. Understanding. So listening, understanding is one by one, all at once. All at once. Writing also. During listening only you are writing it, if you feel it. Okay. Next after that, what are you doing? Are you seeing on the screen or not? Listening, seeing on the screen, and understanding. And the next, are you responding or not? Whoever is responding, they are responding by listening, understanding. Are these things are doing one by one, all at once? Right? During listening, are you taking breath or not? Taking breath or not? Yes. If breathe is not taking, problem will come. And sometimes you are moving your head also or not. Without knowing the head is moving. So tell me, how many operations are doing by yourself at the same time? Multiple. So come on, listen. Coming to the slowly coding level. Listening is an operation. Operation contains what? Function. Next, I am going to introduce what are you doing, as you said that writing. Writing is also an operation. Next, what are you doing? Next, what are you doing? Understanding. Understanding. It is also one operation. Next is called what? Come on. Seeing on the screen. Seeing on the screen. Next, what are you doing? So, you are taking breath also. Next, you are saying what? Moving your head also. Moving your head also. Right? These many number of called what? Functions they are called. How these functions are executed now at your stage? One by one or all at once? All at once. All at once execution is known as what? Concurrency. Spell out. Concurrency means what? Simultaneous execution. Parallel execution is called what? Concurrent execution. You take from my side as a teacher what I am doing, explaining, typing. I am seeing you who is writing, who is not writing, and who is responding, who is not responding. I am also moving my hands. I am also moving my head. I am also taking breath. They are all called what? Parallel operations or one by one? Parallel operations. So what is that parallel operation? Who will provide for us? Multi-threading. What is the use of multi-threading? To provide concurrent execution. Gmail, you take it. Gmail is providing services to one customer at a time or millions of customers at a time. Millions of customers at a time. What is involving there? Multi-threading. So what is the use of multi-threading? It provides concurrent execution. What is the use of multi-threading? Concurrent execution. So as a student, what you are doing? Now onwards, if my Python program is doing multiple operations parallelly, we call the type of program which program? Multi-threaded program. So in order to write the Python program in such a way that we make my functions all at once, I will use the module name called what? Threading module. What is the module name? Threading. NumPy module, Pandas module, CSV module, next is Pickle module. Like that we use some modules or not? Like that we are using called what? Threading module. Using threading module, what is possible? Concurrency is possible. Are you getting my point? Now, one more slowly you need to get it. See our previous diagram. Windows is providing what type of execution now? Concurrent execution. That means Windows OS was developed by using which concept? Multi-threading. What is the use of multi-threading? Providing concurrent execution. See, my dear students, Windows OS is providing the services for Windows command prompt. One separate flow is created for providing the services Windows command prompt. Such a separate flow is called what? Thread we can call. Thread. Separate flow is created for providing the services for Python command prompt. We call it as what? Thread. Windows 10 provide a separate flow of control for providing the services for what again? Thread Python ideally. Separate flow is created for what also? Jupyter notebook. Like the Python will provide, Windows OS will provide a separate flow for what also? Oracle also. It is also provided separate thread for MySQL. Separate flow for what? Paint screen. Separate flow for what? Edit Plus. Separate flow for what? That means Windows OS contains what internally? Threads. Each thread is providing the separate service for every part. So thread is called what here? Who is the ultimate person doing the services to my apps? Thread. So what is the thread definition? A flow of control is called thread. Tell me. Role is called thread. Online students. The way which you are listening the class, one separate flow is created. The way you are writing the notes, separate flow is created. A separate flow is created for every activity. Such activity is executing parallelly without interfering to each other. Such a type of separate flows are called what? Threads we can call. Are you following? So here two things you must understand, students. What is the first one? Thread. What is the definition of thread? Flow of control. Flow of is called thread. One more. What is the purpose of thread, sir? What is the purpose of thread? Very, very easy. Understand? Listen. One type, some block of statements are there in the function or not? From now onwards, tell me who is executing the function from today onwards? Thread. Actually, from the beginning of the course, everybody has to understand that functions are internally executed by the thread only. Today, I will show you the practical proof for it. So, how many functions are there? 6 functions are there. Are you performing all these functions at the same time or not? Yes. How many threads are required? 6 threads are required. In your brain, you are doing 6 activities. 6 flows created from your brain. Those 6 activities are performed by 6 different type of threads. So what is the purpose of thread? Definition of thread is different. Purpose of thread is different. Definition of thread is flow of control. Purpose of thread is operation. Is written in the form of what? Function. From now onwards, functions are containing some block of statements which are performing what? Operation. Who will perform the operation from now onwards? Thread. Threads are meant for performing operation. Are you getting me? So operations are performed by what? So operation related logic are written in where? Functions. So from now onwards, every function executed by what? Thread. What is the thread definition? Flow of control. What is the purpose of thread? It whose logic is written in the form of function. So tell me every function executed by what from now onwards? Thread. How many functions I am having? 6. How many threads I will create? 6 threads. How to create the threads? I will explain. Are you getting me? Now, dear students, take one example. Online students, up to here, is it clear? Is my explanation clear up to here? Take an example of, take one more example. I am coming to one more example, student. Carefully try to follow. Take one example. C programming, you take it. C programming is the one. It comes under non-thread based application. Non-threads. Process-based application we can call. C you take it. C++ you take it. C++ you take it. Languages you take it. Take care. This is my function call. This is my definition of some function. So, language, I will write it int or something like void sum. Void sum. I'll say something like this. I say this. And I'll write some block of statements, guys. I'll write some block of statements. Some block of statements I'm writing. Close. Next I'm writing sub. Like that I will take sub. One more function I will take it. One more function I will take it. One more function. Comes under what you know? Sub. You take it as sub. Now I will write it. sub. Here I am writing function calls. Sum is a function call. Sub is a function call. MUL is a function call. MUL is a function call. This is my main program. And this is my functional area. You also know in our Python also, function calls are there, function definitions are there. So function execution starts from where? Function calls. Now tell me, in C programming, do you know what is happening? I'll write one small red in color. You try to follow. First, in C programming, there is no possibility of creating multiple thread students. There is no library present in C++ programming. That's why those languages are called single-threaded modeling languages, we can call. Single-threaded, also called as process-based applications, we can call. There is no question of creating multiple threads. In that, there exists only one thread is available. Now, this sum function, first coming to where? Sum function call. It will go to your C control will go to sum function and it will execute it. It will execute it and it will, after execution, it will come back to what again? It will go to sub function. From sub function, it will go to sub function definition. Sub function definition. Observe this arrow, students. Observe these arrows carefully. After this sub function executed, it will go to where again? It will go to where again? Multiplication. It will go to multiplication. In the multiplication part, it is going to come to this place and it is going to execute this multiplication. And finally, program execution ends. What is this type of execution called? All at once, one by one now? One by one. This is containing, how many threads are present here? How many threads are present here? Single thread is present. That's why it is going to provide which execution? Come on. Sequential execution. Actually, very simple, students. Sequential execution. Because of sequential execution, what time it will take? More time or less time? More time. So it is taking what time? More execution time is provided. More execution time takes. These kind of applications are called what you know? These kind of applications are called what you know? Heavyweight components we can call. Spell out once. Heavyweight components they are called. Heavyweight components they are called. So students in the class understand it takes us what type of components these are? Heavyweight. Why they are called heavyweight components? Because they're taking more time. They are called as what? Heavyweight component. Thick components we can call. Why this is called heavyweight components? Because there exists only one thread. There is no possibility of creating more than one thread. That's why these applications are called what applications? Process-based applications we can call. Spell out. Process-based applications we can call. Now, what is our present industry says? Think about it carefully. Think carefully. Take your Uber travels, take Swiggy, take any type of business apps, Amazon app. When you install in your mobile, any person can order anything for a particular app. How it works? Is it sequentially works or all at once? All at once works. So internally, every business app is containing what? Threading is permitted. That's why if you go to product-based companies, this multi-threading is most useful. Is it containing one flow or multiple flows are there? Multiple flows. How human being will think parallelly? Like that our program also will work. That I am going to show you now. With the measurement of execution time also I will show you. Whatever I am explaining, I'll show you with the coding. Now coming to here I am going to say one more definition, one more thing I am going to explain. This is comes under Python environment I am taking. Python environment. Python environment. Take care, Python execution environment. In Python execution environment, In Python execution environment, two things I am going to take it. By default Python environment, by default Python environment, by default Python environment I am taking. By default Python environment I am taking. Default Python environment. Programmatic Python environment I am taking. Programmatic Python environment. Programmatic Python environment I am going to take it. By default means what? So far what we discussed it. Come on here also. Strictly speaking, same to same. I am going to write it. Default environment of Python says that take care carefully. I will carry as it is. This part I am going to take up, students. Carefully try to follow. This part I will carry. Here I'll just put as it is here. As it is, I am going to keep it. Take care. Now observe it. When you start your Python program execution, so far you understood who will execute our Python program? Quickly, who will execute our Python program? Come on, PVM. Why difficulty? Who will, after course completion, who will execute Python program? If you say what is the use of it, who will execute? PVM. PVM will come into picture. PVM will come into picture. Okay. Once the Python program started executing, who will come into picture? PVM. The moment when PVM starts, internally it initiates what? It initiates what? A single thread will be initiated. Who will initiate? Single thread. How it is available, you know, one small analogy I will tell you, comparison I will tell you. You are writing the notes with what? Pen. Say, pen. Actually, it is not with pen. It is with refill. Inside the pen, what is there? So you are writing originally on the bottom level with what? Refill or pen? Refill. So on the top of the refill, what is there? Pen is there. Pen is there. Similarly, when we start our Python program execution, who will come into front? Immediately what it creates? Come on. That single thread is something like a refill in the PVM. You try to keep that mind in that, you will understand like anything. Who will execute our Python program? PVM. PVM initiates what? Thread. That thread only will execute my program. As usual, students, careful. This void I will remove. This void I will remove. And this part also I will remove. This brackets I will remove. Because these are the syntaxes of what language? C language. I'll remove this. Now I'll take out this. Now I'll write what keyword there? DEF I will write it. DEF. DEF I am writing. And I will write something like, you know, colon. Here also I will write a DEF. DEF. Also colon I am writing. Also colon I am writing. Here also I am writing DEF. Something like colon I am writing it. Are you able to follow? Now tell me, the PVM initiates with a single thread and the single thread will execute my functions one by one and it is going to be taken as which execution? Sequential execution. So by default it contains how many threads? That thread name is called, today you must remember, students, main thread. Spell out. Main thread we can call. I'll show it in the program. I'll print the name and I will show you. That main thread will execute my sum function, sub function, multiplication function, everything. So three functions are executed by which thread? Main thread. By default, how many threads are there in the Python program? Only one thread. What is the name of the thread? Main thread. Main thread is initiated by whom? PVM. By default, how many threads are there in Python environment? That single main thread will execute the main program entries, plus it will execute the normal functions also. That is the programmatic environment or default environment? Default environment. Online students, did you understand up to here? Did you understand up to here? Further, I am going to enter. Everybody, Default environment is done. Now I am going to which environment? Programmatic environment I am going to take up. Carefully follow, students. Now I am taking same function. I am going to keep it here. Observe it. Now I am writing like this. Some function, sub function. Who is going to start the execution? PVM will come into picture. See the carefully. PVM will come into picture. Now I am writing here PVM. PVM will come into picture. Very carefully you take it. PVM will come into picture. Now I am going to write it PVM. Now I am going to write it. When the PVM comes into picture, what is going to initiate? Come on, main thread. Main thread is going to initiate. I am writing something like a main thread, empty. I am writing something like empty. That empty is going to internally create what? Subthreads I am going to create. I will write a code for what? Separate thread I will create to execute which one? Sum. I'll create a separate thread to execute what? Sum. I'll create a separate thread for executing what? Multiplication. This T1 I will create. How you can create? How easy? How do you create a list object? How do you create a dict object, tuple object? How easy it is? Like that I will create. What the class name I said? Thread. Threading is a module. Inside the threading, there is a class name called thread. Of course, I will explain in detail just because you know already the coding T1. What is the T1? Object of thread class. Just remember, object of L1 is equal to list of. T1 is equal to thread of. Like that. What is the next? What is the next? T2. What is the next? T3. T3. T3 is the next. T3. T3 is the next. How many threads I created? T1, T2, T3 are subthreads we can call. For their subthreads. Here T1, T2, T3 are called, come on, subthreads, are called subthreads. Because of the subthread mechanism, what advantage is coming? All at once I can execute. Because of all at once execution, am I getting less time or not? All these things I'll show programmatically. Simple student. Suppose you come to this default environment. You are only the one. You have 3 works with you. You are only doing one after the other. It takes, for example, 90 minutes it is taking. 30 minutes, 30 minutes, 30 minutes. And in the second case, what are you doing? You are the one. You are calling 3 friends of yours. 3 friends are coming to help you. These 3 friends are completing everything in how many minutes? 30 minutes you are completing. So which one is the faster one? Programmatic approach is faster one. How many threads are there in programmatic? 2 threads are there. One is which thread? Main thread is available. Second one is available what now? Subthreads are there. Maybe so many number of subthreads are there, but all subthreads are comes under one category. Main thread will comes under one category. So programmatic contains how many threads? 2. One is main thread. One more is like a teacher in the class is main thread. Students in the class are subthread. Understand my point? So which one is the fastest one? Right. What is the main thread will do that time in the programmatic? It will execute main program entries only. Subthreads will execute what? Functions will execute. If we go to default environment, main program entries plus what? Functions will execute by which thread only? And in the programmatic, main thread will execute which program entries? Main program entries, and subthreads will execute my functions. These points, if you remember, it is more than enough. I hope you are getting it. Main thread will execute main program entries. Subthreads will execute my sub functions. Got it or not? So finally, sum, sub, multiplication are functions. Default thread, main thread. T1, T2, T3 are called what? Subthreads. They are executing my functions one by one. And all at once or one by one? All at once. We are going to see that. First of all, are you okay? And the left side one, C language you see once. This is called which based application? Process-based application. What are the qualities of process-based application? Process-based application contains how many threads? Provides which execution? Sequential execution. And it takes what time? More execution time. And they are treated as which components? Heavyweight components we can call. When you come to thread-based application, Python environment is one of the threading-based application. It is containing how many threads? Multiple threads. Always I will consider this. This is called what? Thread-based application we can call. In thread-based applications, how many threads are there? Provides multiple threads. Second one provides which execution? It will provide a sequential execution as well as concurrent execution. Here you see sequential execution. Here you see concurrent execution. Takes what time? Less execution time. And it is going to give you what? Lightweight component it is called. Less time taking lightweight component or heavyweight component? Lightweight component. Are you getting me? So take our any business app as on today internally uses threads. Getting confidence, huh? So if you are going on the way, what are you doing? What are you doing? Just tell me. Are you watching the front or not? Something you are thinking in your mind or not? Talking to your friend or not? Watching to your somebody else who is coming opposite you or not? How many flows are there in your brain? That is called what thinking? Multi-threading. Multi-threading, right or not? Right. So, yeah, the human being is thinking naturally. It is also in artificial intelligence, this is important, students. Because internal product level, this threading concept will come into picture. Right? As on today, no company people are asking interview-based questions in multi-threading. There is no doubt in that. But we should not leave this topic. We have to learn it. When you go to big companies product level, they will ask you these questions. And as on today, our students did not get a single question in interview point of view, these questions. But when you go to bigger companies, definitely these concepts will come. Up to 2 to 3 months back, there was no whoops questions are asking. But these days, they are asking whoops related questions also. That's why we must be careful in understanding all sorts of topics. Right. Online students, up to here, is it clear and careful? Now I am going to show you some small description. I am going to show you, students. Some small description I am going to show you. Instead of typing this entire thing, some small description I want to bring it. Let us come to your place. Now there I want to create one small folder and I'll show you the examples for it, threads. Under that, I'll take one small notes. Under that, I want to give you small introduction. So types of applications in threading, I just want to take up. Please read out carefully, everybody. The purpose of multi-threading is that to provide a concurrent execution, simultaneous execution, or parallel execution. That is executing all at once. In industry, we have two types of applications or languages. They are process-based applications, thread-based applications. Number one, process-based application. Process-based applications contains single thread. Process-based applications provides sequential execution. Process-based applications takes more execution time. Process-based applications are treated as heavyweight components. Examples are CCPP. Comes to next what? Thread-based applications. Thread-based applications contains by default single thread. And programmatically we can create multiple threads. Come on. Thread-based applications provides both the sequential execution and the concurrent execution. Thread-based applications takes less execution time. Thread-based applications, come on, are treated as lightweight components. Python, Java, C#, .NET, etc. are comes under which applications? Thread-based applications. Clarity is there? Now I want to go for thread-based application introduction I will give you. Just carefully follow me. I'll show you that. Carefully follow. All of you. Start. Thread-based applications. Start. The purpose of multi-threading is that to provide concurrent or simultaneous or parallel execution. Concurrent execution is nothing but executing the operations all at once. The advantage of concurrent execution is that to get less execution time. If a Python program contains multiple threads, then it is called a multi-threading program. Are you understanding this advantage? Less execution time. In olden days, you see, when you go for banking, all the people are standing in the queue. To avoid that, they've gone for threading model or not. Multiple ATMs started. Any person can go to any ATM, they can do the parallel operations. That is the best example of threading. Come on, definition of thread. Start. A flow of control is called thread. The purpose of thread is that to perform certain operation whose logic developed in functions or methods concurrently. Are you getting this? Flow of control is called thread. Every person will ask you definition of thread. Flow of control is called thread. Each thread is doing certain operation whose logic is written in the form of function, or if it is a oops, we call it as method. If it is a functional programming, we call it as function. Good. Careful. By default, every Python program contains a single thread. Diagram also said, na? Diagram also. See the diagram? Python execution environment, default environment, single thread. What is its name? Main thread. Read out. Come on. And whose name is main thread. And it provides a sequential execution. Programmatically, in Python program, we can create multiple sub or child threads. And whose purpose is that to execute operations whose logic is written in functions or methods concurrently. Are you following? Programmatically, in Python program, we can create what? Multiple subthreads or child threads, whose purpose is that to execute operations whose logic is written in functions or methods concurrently. Did you understand? So subthreads purpose is to execute the functions whose logic is written in functions. Got it? Now, hence, programmatically in a Python program, two types of threads are there. Main thread, sub or child thread. Who is creating main thread? Very good. Who will execute the program? PVM. PVM initiates what? Main thread. Main thread, with the help of our coding, that will create what? Subthreads. Subthreads will do what? Operation. Operation result given to whom? Main thread. So what is useless there? Subthreads completed the operation. Subthreads are collected by main thread, hand over to whom? Garbage collector. And main thread also will destroy. That is called end of the program execution. Will you understand the flow? You are going on the way and you are having lot of thoughts. When you go to your room, you will sleep. What are the things, what thoughts are destroyed? The multiple flows you thought on the road are just destroyed. Same thing here also. Subthreads are going to be stopped once that operation is completed. Come on. Main thread is created, initiated by PVM when the program execution starts. And whose role of main thread is that execute the main program statements and monitor the execution status of subthreads. If subthreads present, if subthread present only. If subthreads are not there, main thread only will do everything. Next, subthread or child threads always executes operations whose logic written in functions or methods concurrently. Subthreads will do what? Main thread will do what? First, we need to have the clarity. Are you getting? Suppose you are there, guys. You are there in your family, in your home. Your parent is there. You are not there. You are there in somewhere else. Your parent only will do all your operations. You are there and his parent is having two kids. Two kids will do two different operations. So it is nothing but less time taken by the parent. So parent will do some operation. You will do some more operation. Parallelly, that will be done. So here, main thread will execute the main program statements and subthreads will execute the functions. Are you getting? So, online students, This wording is important. Main thread will do what? Subthreads will do what? Now I am going to show you some program now. Because of thread usage, what is an advantage? Without threads usage, what is the limitation? I will show you. So, online students, instead of 1 or 2 members response, please respond all of you who are all understood. So, this part, now I am going to write the coding for it. Now, carefully understand. Now, I am going to start. First program. What is that now? First of all, whether thread is there or not, I want to say. Now I am going to say print of program for finding name of what thread? Main thread. Don't try to understand the library, students. Module, don't try to understand. See the results of today. Next class, I will tell you the library for you. Okay. Now I am saying a name of thread. Default name of thread and default name of the thread. Actually, we did not print so far, but thread is there internally, comma. Something I will write it that you least bother about it. Threading dot current underscore thread dot name. You don't worry about it. What is there? Import what? Threading. What is threading? But one thing you understand. What is threading? What is the current thread? Function. Method is there inside the class. Module name dot function name. It is called function name only. Method is present in where? Class. Function is present in where? Module. This is very important. Function and function method logic is same. Methods will be with self, CLS, etc. And a function will be not containing self and all those things. You know better than me, which I explained so many days. Now you execute this. What is this now? Default thread example.py. Save this code. Go to this location, students, and try to save it. Come to the command prompt. Here I am writing d::kvr python 6 p.m. cd threads. Now I am writing py, writing like this. What is the answer? Come on. Main thread. Simple. You see, then the split session. Make it I'll get it. So T is equal to like this. I'll say like this. And I'll print just T. Easy. Today itself you can understand. It will print some description, student. What it will print? My thread name. Every thread will have some ID will be there. Suppose as your bank transaction is performing, one transaction ID will be given or not. Like that, when the thread is started, one ID will be created by the OS for you. See that? Execution done. What is this now? Name of the thread. Started with what ID? Again you run it. Some other ID. What is the name? A runner is having some number in the neck or not? Like that. Main thread. How do you get that main thread? There I am writing T dot. What I am writing? Like A is equal to 2 plus 3j. A dot real. We are saying now. What the real is giving? Like that, this thread dot name. When I say dot name, this will be obtaining. That will be obtaining. I am writing something like that. Execute it. What is printed? Main thread. Instead of that, combine everything. I am saying here I will write a T dot name. I will write it now here that you least bother about it. I will write here T dot name. I am writing it. T dot name. I am writing it. See the answer now. Main thread is printed. Are you following me? Following or not? Yes. Coming to don't sleep. Black shirt. Sleeping. I am seeing and you are saying no, sir. For certain things we should not tell lies. Any problem? Huh? Yes, sir, I am sleeping. What is that? Now I say wake up. Sleeping now? Yes. Wake up now. Now I am going to say T dot name. It's not only happening. Every class, 1 or 2 members are sleeping. I am saying wake up, wake up. It's natural. But these days, I don't know why people are sleeping. These last 1 month only, I'm finding. Earlier, I used to find rarely. Now, these days, I'm finding every class, one person is sleeping. What is the nature effect or not, I don't know. But somehow it is happening. Even I am not disturbing sometimes because when they are in deep sleep, if I disturb now, health problems will come for them. That's why. Now, threaded dot sleep. Amol, threaded dot sleep. I'm going to use today. Already we used sleep function in where? Reloading module time. Right. Time dot sleep. So, time module. Now coming to the point of it, one more example I am going to cover. What is the example I am going to tell you? Look at. I want to show you default environment, programmatic environment with the time measurement. I said heavyweight component and what? Lightweight component. So don't feel, students, when I wake up you, don't feel it. Okay? Don't feel it. So only simple hope is you will follow me. That's all. Now I am writing program for demonstrating non-thread based application. Non-thread based application. That is nothing but contains only which thread? Main thread, but not subthreads. Subthreads are not there. Only one person doing everything, heavyweight. Right or not? See what I am doing. DEF, one small function. Hello. I am writing. Now I am writing print of hello function executed by I am writing dot format of threading dot current underscore thread dot name, which will print the name of the thread executed by hello function. Similarly, one more function, very simple example. Later I will go to big example. One more function, hi. I am going to write it hi function executed by same. Now I am writing here. Welcome. Now I am writing welcome function. I am going to write it like this. Now I am writing something like this. How many functions I am having? 3 functions. Okay. Coming to main program. See, students, program execution started. Program execution started by, I'll write it dot format of this line I am writing. Okay, writing. Which thread it is? Answer is coming. Main thread. Okay, see, I am writing here. What it is now? Non-threads. Example1.py. With the threads I will execute. Right now, least bother about it. Just to see the output. That is what I am expecting from you. Understand the timing of this. Execute it. Go to the place. Py. What is the threading import? Import what? Threading. Import threading. Okay. See, students. Execute it. Program execution started by what? Main thread. Program execution started by main thread. Okay. After that, what I am doing? Carefully observe. Print of. Now I am going to save. Tell me now, what should I do now? After this is there, I want to call what? Hello. Next, hi, welcome. How do you call normally? Hello. Next, hi. Next, welcome. How it is coming, you see. My dear students, I'll go to that. Hello. Now I am writing line number, just for you to understand, line number what? 17. Next I am writing after hi, line number what? 19. After that, what is happening? Program execution ended. Be careful, ma. Program execution ended. This is called what? Line number 5. 5. Line number 8. Line number 8. Why I am writing all these things, to show the flow. To make you to understand that only one thread is executing all my functions. 11. Line number 11. This is called line number 14. Line number 14. Line number 14 is what? Execution. Line number 21 is called what? Ending. Ending. Program execution started, program execution ending. See that this is called 22. Okay. Start the flow. Where is the line? What is the program coming to? 14th line printed. 15th line is printed. Hello. Where it is going? Come on. Where it is going, students? It is going to. Who is going to this place? So far we said PVM is going. PVM related. Created thread is going. Who is that? Main thread. Line number 5. Hello executed by what? Main thread. From there it is coming to where? 17th line. It is coming to main program. After that it is going to where? 18th. 18th to where? 7. 7. 8 executed. From there it is going to where? 19. Welcome. It is going to welcome function. It is executed. Again going to 21 and 22. That indicates total functions are executed by what? Come on. Main thread only executing all of them. Please observe that. That is what I want to convince you here. See that, ma. Line number 14. Line number 5. Hello. Main program. Again function. Main again here. Line number 11. Which thread is executing everything? Main thread, main thread, main thread. It is called what? One after the other is executing. By default, how many threads are there? One thread. Sir, can you show one thread counting, sir? That's what I want to show you. I will say, don't worry about it. I'll say number of threads, default number of threads in this program is equal to threading dot, how simple, students, active underscore count. చదువుతూనే అర్థమైపోతుంది మనకు. Active underscore count. What is that? How many are active? One thread only. That one will print. One will print. See that? How many are printed? By default, how many are there? That is called what? Default environment. It's a very frequently asked question. How many threads are there by default? One. That one thread is executing what statements? Main program statements and subprogram threads also executing. Understand? It is known as what? Heavyweight component it is. Same program, I will convert into what? Threading. Online students, did you understand this flow, students? I'll go to my logic. Very simple. Go to that. One more example I will give you. Nothing to worry. Here you go. Here I am saying, see, what is this now? Threads. Program for demonstrating thread-based application contains main thread and yes. Now and what? Subthreads. Example 1. Threads example 1. Subthreads example 1. Main subthreads example. Both of them are there. Okay. Take care, students. Now I am writing these lines. You keep it as it is. Okay. Now start. Here I am writing. Today, main thread I will execute what only? Main program. And these threads I am appointing somebody to execute the 3 functions. 3 functions want to execute separately means what I need. See that, observe it now. What is that? Right side programmatic, you observe it. What is this now? How many threads I want? So I have to create how many? 3 threads I will create. Each thread is targeted to what? Some. T2 target, T3 target. Go to the place. Come on, students. Now I will create. Come on. Create 3 subthreads. Create what? 3 subthreads. Can I create 3 subthreads now? Create now. How do you create a list? L1 is equal to list of. How do you create tuple? T1 is equal to tuple of. How do you create dictionary? D1 is equal to dictionary of. How do you create student object? S1 is equal to student of. How do you create a thread? T1 is equal to thread of. Thread is a class which is present into threading module. How simple it is, students. Threading dot thread of. The T1 is target to whom? T1 target is one keyword attribute. It's a syntax. T1 is targeted to execute what? Hello. I will write function name only. Don't write within the double quotes. Hello itself is a function name. Function name itself is an object. Hello. Of course, later this is args also will be there. That I am not worrying today. Next example I will tell you. This indicates T1 thread is targeted to execute what? And I am saying T1, you go and execute what? Hello. What is T1? Here, T1 is object. That is a subthread object of what? Thread. Called what? Subthread. It has name, students. And its default name is thread-0, thread-1. What is T1? Object of thread class. What is it? It has some name internally. What is that name? Thread1. What is the main thread name? Main thread. What is the subthread which I created? Thread1 by default. Similarly, one more. Create. T2 is equal to thread of what? Hi. I will write one more. What is this thread to? T2. T1 is called, T2 is called what? Object. Now I will take one more is called what? T3. Threading. What I am writing now? Welcome. Welcome of, don't write ma. Welcome, only name. What is T3? Object. Thread-based application. Default name is what here? T3. Are you following me? How many threads are there? 3. 3 are ready. They are just targeted. Next, what I will do? I said, you do this, you do this, I will do this. I said, I targeted already. I need to say what? Bus is filled. Target. You need to go to this station. You need to go to this station. Bus is ready. Passengers are full. What should I say? Need to dispatch. Need to start. For that, I say next word. Dispatch the threads. Dispatch the threads. Dispatch the subthreads. To dispatch the subthreads, T1 dot, what is the function name? Start. Next, T2 dot what? Start. T3 dot start. Are you following me? T1 dot start, T2 dot start, T3 dot start. Are you getting my point? Good. Now, students, after T1 dot start, do you know what is happening? Who is dispatching the subthreads? Main thread. Who is creating the subthreads? We are writing the code which is created by the main thread. And the T1, T2, T3 are the threads which are dispatched. T1 will go to hello, T2 will go to hello, T3 will go to welcome. What is printed? Thread 1, thread 2, thread 3 will print. And who is printing at the end of the thread and beginning of the thread? Main thread only will print. Are you following me? Active thread, don't worry. After 2 minutes, I will show you again. Execute it. See, students, go to this place, save this, try to understand this questioning here. PY, see, students, see the answer now. Program number, line number 14, which is thread? Hello, executed by what? Line number 8, executed by what? Thread 2. Line number 11, executed by what? Thread 3. Each thread is targeted to the particular function or not? Ending by what? That indicates main program statements are executed by main thread. Some subprograms or methods or functions are executed by subthreads. So which is better? Second model is better. With a main thread and subthread model is better because it will do the program execution faster. This is only code is shown. Now I will measure the execution time. Can I go for execution time now? Online students, did you understand the second program, guys? First program, everything executed by main thread only. Second one is going to execute each function executed by subthreads. Following me? You take IRCTC project, railway reservation. You take Abibus, any bus reservation system. All of them are internally containing what? Threading. Internal components providing concurrency is threading. Now I'll take one more example. Ultimate example I'm going to take. Take care and follow me carefully. Now I'm going to write it. Program for that same example I will continue. Demonstrating this I will write it. I'll carry this. Now I'm writing. Sorry, students. So I will carry this. This part I will carry. This I'll try to write it. Now I am writing non-threads example. Non-threads example2.py. I am taking main program. I'll take the same example here, students. Take care. This line number 4 and all those things you need not to worry about it, because already you understand that line numbers in this code. Again, I am coming to this printing of main thread. Here I am going to write it. LST is equal to some 12, some 4, 15, some -5, some 16, some 19, something like, some 25 I am taking. And I am taking something like 8 I am taking. For these numbers, I want to find the squares as well as cubes I want to find. Squares is one operation, cubes is another operation. What I do now? Squares is one function. Squares of what I will say? LST. Cubes, I will take one more type of time, LST. Now take care, and I will just take like this. So take care, guys, all of you, and try to follow me. Now see, I need to define how many functions? 2 functions. DEF squares of what? LST. Now I am writing. What I am writing? For value in where LST, I will say print of, I am writing the thread name. And I am writing square of value is equal to result. Format of threading dot, come on, current underscore thread of dot what? Name, comma, value, comma, value star 2. Are you getting me? Value star 2. This is thread name is printed and square of that number and whose result is printing. Value and value star 2. You know this? And I want to print this with some time of gap. Sleep of 1 second, I will say. Got it up? Done. This is for what? Squares. This is for printing squares. Now, similarly, I'll go for what? Cubes also. Same to same. Cubes also I will go for it. Cubes. Now I am writing cubes. There I am writing. Cubes I am writing. Now I am writing here. Cubes I am taking. Value, comma, val star 3 I am taking. Time dot sleep. As usually you take it. Now program execution ended. That also I will take it. Coming to back. Here you see, students, is ending by this. So line numbers you remove it. Are you following me? Now carefully follow. Start the flow here, everybody. Import time module, threading module, everything. Import threading, comma, time. Start first square. What is the thread is printed? A main thread. Main thread is coming to where? Squares. It will go on printing. After completion of that, it will come to main program. This line is printed. Again going to where? Cubes. Same thread is printing cubes also now. See the result of that. See the result of that. Execute it. See the answer of it. Now I am measuring the execution time. Very shortly I will measure the execution time. See the answer of it. 12, 14, all those things. Main thread only printing squares. Later it will come to main program. It will come to cubes function once again. Again it is printing it. That means one thread is executing how many functions? What type of execution it is? Sequential. Come to back. Now I want to measure the execution time. Online students. Output is try to study the output. This one main thread and ending of the main thread, each function executed by main thread only. It is definitely what? Time consuming component. I will measure the execution time. How do you measure the execution time? I'll come to the class at 6:10. I'll stop the class at 6:40, so 7:40, 7:35, 7:45. Depends on our classroom completion. I will take it. Beginning time. And 6:10 is starting time. Ending time is what the timing I am taking. I will record that. Ending time minus beginning time is equal to total number of hours. Right or not? How do you take it, mom? Time dot time. Time is a module. Inside the time, there is a function name called time. It will record the hours, minutes, milliseconds also it will record. Seconds, minutes, hours also it will record. Now, ending time also you take, guys. Ending time also. Ending time also I am taking ET. What is the completion time? Come on. Total execution time. Total execution time by which thread program? Non-threads program. Non-threading program. Non-threading program is equal to dot format of what? ET minus BT. ET minus BT. Are you getting? Ending time minus beginning time. Are you getting up? Okay. Execute it once again. See this now. It is going to give you the number of threads are how many here? How many? One only. One thread only. Number of threads are one only. See that it is going to give you the time of that. How many? 16.01, 16 seconds, 0180, etc. milliseconds is taking. That is my timing of this program. Same program I will do what? With the threads I will do it. Simple. I am the one. I am executing by squares and cubes. I'll call two my friends of mine. I'll ask them to do it. They will execute parallelly or not? Which one is taking less time? With the friends, what I'm executing will take less time. Go to the same program. See students, I'll carry this. I'll carry this logic. I'll take up. I'll modify. See that. With the threads, I will do it. With the threads. Earlier what? This logic. I'll take the same title of it. Same title of it. Go to this place. I'll write it. 2.py. Today, this one, squares is there. Everything same. But the only thing is, here I am writing my logic. Create what? Create what? Two subthreads. Two subthreads. Two subthreads I am creating. How do you create, mom? Tell me. T1 is equal to threading dot thread of target is equal to what? Squares, comma, arcs is equal to target is equal to squares, arcs is equal to LST, comma, you need to write. It is a tuple format you need to pass. I'll explain that, nothing to worry. Actually, very easy. Arcs target indicates what? Name of the function. But this function is taking parameter now. To pass the data to the parameter, you are using one built-in attribute called arcs. What are you supposed to pass? LST, comma you need to say, because arcs always takes in the form of tuple format. Tuple format. I hope you are getting it. Now, If you are not getting it, I'll go for it. Once you go to the Python environment, go to Python environment, A is equal to 10. Beginning level, if you open your notes, type of A. What is the type? No, it is an integer. It is an integer. Integer it is. Now I say comma, I said. What is the type of A? Tuple. That's why arcs of LST comma. That's why. I hope you are following. That means T1 is going to squares by carrying which value? That LST values are put it into this LST and it is executed. Who will execute? Thread 1. T1. What is the T1 name? Thread 1. Already said in the previous program. Already said in the previous program. What is this T1 is called? Object. And this is called object is created. Object is created. Sorry. Done. What is the name? Thread 1. I hope you are following. Similarly, you create one more now. Similarly, you create one more now. Sorry. So similarly, you create one more now. T2 is equal to what? Cubes. Say cubes. Come on. What is the LST? Same parameter you are passing. T2. T2 you say. What is its name? T2. Thread 1 will print squares. Thread 2 will print cubes. How simple it is. Now say what now? I'll say start. Start I will say. And these things I need not to write. See students. T1 dot what? Start. Next up. T2 dot start. How many threads are there in my program? Here I will count the threads. Print of number of threads. Number of threads. Before subthreads creation. Before subthreads starts. Subthread starts. How do you write it? Threading dot current active threads. Active underscore what? Count. How many? 1 will print. 1 will print. Here after starting, number of threads after subthread starts. After subthread starts. How many? 3. 2 subthreads, 1 main thread. Total how many? Very good. See students, see carefully. T1 and T2 are dispatched. They go forward, squares and cubes, they are going to combine together, giving the result parallelly. Right? And don't think that they are going to see the order. Squares first, cubes first. Don't think like that. Don't be like a sequential student. When you are reserving Abibus and I am reserving Abibus, are we seeing the sequentiality? You are doing your own operation, I am doing my own operation. I am using a single terminal here. That's why they are showing combined results are coming. But we can clearly understand thread 1, thread 2, thread 1, thread 2 will come. Okay. Who will execute the main program entries? Come on. That means if I start my threads, who are going to my functions? Subthreads. When the subthreads are going to my functions, what is line number 25, 26, 27, 29? Who will execute? Main thread. Actually, main thread has to execute that highlighted lines 25 to 29 when? After subthreads execution. Yes or no? If I don't do that subthreads execution after that, unnecessarily you'll get wrong answer. Let me execute once. Let me execute and show you. I'll show some wrong timing measurement. Then you can understand. Go to that. This is called 16 point something. You execute it. What is that now? Example 2.py. See the answer now. See the total execution time. You see 0.00 is coming. What it indicates? Before my subthreads execution, it is main program is showing what is the total time. Are you following or not? But actually it is wrong now. Even after showing that, it is showing what? Still subthreads are executing. That's why what you do is after completion of it, you do one thing, students. You ask your main thread, you please wait until T1 and T2 join with which thread? Main thread. You are sending, go and execute, but you wait there until who will complete? Subthreads. Simple. Your parent brought you to the shopping mall. Yourself and your brother, both of them are going and you are doing the shopping mall. Your parent is waiting until you go and join with him after the shopping. Like that. For that, I am writing one simple line, students. Don't worry about it. I will explain next class. Join the subthreads. Join the subthreads. How do you join? T1 dot join, T2 dot join. What is the use of join? Actually, you can understand easily. You are making the subthread to join with which thread? After completion of subthreads. So main thread will be there at line number 27, 28 only. It will wait until what is completed? Subthread. Now I will print it. Same thing. Here I will write it. Here I am writing. See. Number of subthreads after subthreads completes. How many? Good. One. One only. Why? Subthreads are destroyed. Their work is over. I will destroy. How many are there? Beginning. After starting. 3. After completion. That's all. That is called internal flow of threads. See, students, online students, getting or not, execute my program now. Before the program output you are remembering, I hope so. Previous program you execute. See the program previous execution, non-threading example, non-threads example. Actually, if you understand, there is a more meaning in this. So it will take some amount of time. Timing is called what? 16.02 something. Some slight changes will be there in the processor also. You go for executing what program now? Subthread execution number 2. 2 now I am going for. Careful students, 16.02 non-threading. Same example I am doing that. See that how many threads in the before start? After that how many? So the output is coming. The output is coming. Still I did what program I said. I hope I did not save it, student. I did not save it. I did not save it. Okay. Last and final. So this I will execute. I did not save it. I made changes, but I did not. Non-threading example with the squares and cubes. And don't ask me, sir, here order is coming, there order is not coming. While you are doing any online transaction, we never bother about the transaction order. We bother about whether the work done parallelly or not. So see the answer now, 16.01 again. Now you see that. How many threads are here? 1. After the thread starts, how many? 3. Take care. Thread 1, thread 2. Thread 1, thread 2 parallelly coming. What is the number of threads after completes? 1. What is the execution? What is the execution lost up to main thread is there? What is the timing? 8.00. Earlier program output is how much? 16 point. Which one is called a lightweight component? Threading. So which one is a faster in real time as on today? Threading. That's why every real time application contains internally what? Threads. In the coming days, the plan of the industry is the threading want to be provided by the internal programming itself. Because writing the program for threading, people will feel little difficulty. That's why they are introducing, including in the product level itself. Like Windows OS is the best example. Windows OS will provide the parallelism for all the applications to provide the services. I hope you are understanding with the timing also shown. And you observe it. What is happening here? You see the diagrammatic representation now. With the threading, what is happening? With the default environment, what is happening? With the programmatic environment, here 16.01, here almost 8.0 is coming. So programmatic is the best or not? Concurrency is provided. That's why I wrote it here. That's why I wrote it here. Types of applications, if you remember, thread-based applications are and process-based applications are heavyweight. Understood? So now in today's session, you understand thread-based application, definition of thread, purpose of thread, introduction you understood, main thread and default thread, that is a subthread. And one small example you have seen. Tomorrow class when I come back, I'll explain the detailed explanation of threading. I will explain these approaches also. Of course, in my example, one of the approach I used it. Tomorrow class when I come back, we will reveal that what is that mechanism of internally. Understood? So I'll stop my class and tomorrow class don't miss it. Online students, you can hold on. I can explain you after this completion. I can explain any doubts are there. Did you understand? Tomorrow class, don't miss it. I'll go for the second level explanation of threading. Don't miss it. Thank you. All the best.